Our body regularly encounters pathogens such as bacteria, viruses, protozoas, and other pathogenic microorganisms. Some of those microorganisms are but just microbial flora, and they're not harmful. But some of those microorganisms are pathogenic. So you see some of the microorganisms, all different types of microorganisms, and this one is showing you the skin, and that's the hair follicle right over here, the hair showing. So this is outside the skin, and the bacteria try to get into the circulation inside the cell. So our skin basically forms a physical fence. They're basically creating a wall, and through this wall nothing could pass. So bacteria cannot go from outside into inside our body. So our external cutaneous membrane of the skin and our internal mucosal membrane blocks pathogens from entering into the body. So they're kind of like saying, stop, you're not allowed to go in. So they're basically blocking any entry of the pathogens. In addition that they physically block it, they also produce chemical substances to further reinforce the wall and create undesirable environment for the pathogens. For example, they make secrete acid, they may secrete antimicrobial agents, or a mucus, thick mucus that will basically trap and destroy pathogens. On the other side of this fence, on the other side of this wall, which is the mucosal membrane and cell, there is army of non-specific cells such as macrophages, dendritic cells, M cells, natural killer cells, constantly monitor. So they're basically waiting over here. So this represents like the one of the non-specific cells. They constantly watch and monitor in case of any pathogens gain access to the inside, they will destroy it. So for as long as the membrane is intact, no pathogen could gain entry onto the cell. So all the cells like macrophages, dendritic cells and M cells, T cells, B cells, natural killer cells, all of them are basically ready to attack any pathogen that may enter the cell inside the body. Now, if you look at the M cells over here, dendritic cells extend their hand out, and they're kind of like basically sensing any pathogen. So they're looking for any pathogenic bacteria, and they're sensing any pathogenic microorganism out there in the mucosal membrane. If there is damage to the cell, so if the skin or the mucosal membrane is damaged, or there is injury, then all these pathogens will try to enter into the body. So those pathogens will rush in and try to enter the body. Once inside the body, the pathogens, so those are the pathogens that manage to try to get into the body. Once inside the body, they will be immediately attacked by macrophages, dendritic cells, and others. So once the pathogen is inside, macrophages will move and engulf. So the green one is the bacteria, and the macrophages will engulf that pathogenic cell. Also, dendritic cell will go and internalize the pathogen. So bacteria is internalized by the dendritic cells. So basically, pathogens will take the microorganism and engulf it. Basically, eat the microorganism, internalize it. So macrophages, natural killer cells, and other lymphocytes basically will rush into the site of injury and kind of like capture those pathogenic cells and destroy them and engulf them. At the same time that macrophages, natural killer cells, dendritic cells destroy the pathogens, other cells like basophils and mast cells will release anti-inflammatory chemicals to reinforce the defense. So as you could see, the basophils basically release chemicals, and mast cells right over here releases those anti-inflammatory chemicals. And so the anti-inflammatory chemicals include histamine, heparin, and other vasodilators to reinforce the defense. So right over here, what you see, this brown one is the infected cell or unhealthy cell. And this one is the natural killer cell. So the natural killer cell produce those chemicals, perforin. So natural killer cell came close to the infected cell and produced those chemicals. So what those chemical perforin does, perforin binds to the membrane of the infected cell and makes a pore or a puncture and made a hole in the membrane of the infected cell. And once it made a hole through the membrane, another chemical that's called granzozyme will enter through this hole into the nucleus of the infected cell. Once inside the nucleus of the infected cell, it will initiate the apoptosis process and the cell will die. Now how? So this is the antigen that basically the cell will bind to the antigen over here and will internalize, engulf the antigen. And those ones are the lysozymes. They're filled with the digestive enzymes. So as soon as this is internalized, this digestive enzyme will go, lysozyme will go close and release the digestive enzyme and break this antigen into tiny pieces. And then MHC class 2 protein that are produced by the cell, they will pick up a tiny fragment of bacterial or viral peptide and they will deliver it to the surface and show it to the T helper cell as evidence. So you see antigen is internalized and then the lysozymes move close, release the digestive enzyme, break the bacteria into tiny pieces, and then MHC class protein comes and picks up a piece and presents that piece to the T helper cell. So this is the T helper cell. The T helper cell looks at the evidence and becomes stimulated. So the T helper cell is convinced that we're infected. T helper cell will present this evidence to B cells. So once the T helper cell basically presents the evidence to the B cells will become activated. B cells will proliferate. They become more numerous. And some of those B cells will become plasma B cells and some of them become memory B cells. The plasma B cells will produce antibodies. Basically, when pathogens enter the cell, this pathogen is engulfed by the macrophages. At the same time that macrophages destroy the pathogens multiply. So the speed at which the pathogen, or at the rate which the pathogens multiply compared to the rate that they've been destroyed is different. They multiply much faster compared to they've been destroyed. So macrophages and natural killer cells need help. So what they're going to do, the dendritic cells and all of them, they need help. They will go to the lymph nodes and the lymphocytes and they will present the evidence. They will ask the helper cell to help. So the macrophage will call the helper cell, I need help. The helper cell will obviously show me some evidence. And what is that evidence? The evidence is that T cells have to check the MHC class 2 protein. If MHC class 2 proteins don't have any antigen, viral peptide or bacterial peptide, then T cells will ignore the call. If the MHC class 2 protein is attached to some kind of pathogen, then they will respond. So the macrophages will basically show the evidence. In this case, they're going to take a piece of bacterial peptide and say like, hey, you see this bacterial peptide? That bacterial peptide or that viral peptide is the peptide that the bacteria or pathogen that infected us. Looks like this. So now the T helper cell has some information how that pathogen looks, what is the shape, what is the configuration and form. So they could inform the B cells to produce that specific type of antigen. So the T cells will say like, all right, I have the evidence, I check the evidence, I will go tell the B cells, and then the B cells will be activated, stimulated, and they will produce antibodies. And once antibodies are produced, antibodies will go after the pathogen, bind to the antigen that's found on the surface of those pathogenic cells, and stimulate the macrophages to destroy. So you see how from non-specific it moved to a specific defense. So macrophages, dendritic cells, natural killer cells, all of them were non-specific defense. They were the first to attack the pathogen, and it took them time until they came to the lymphocytes and lymph nodes, and they presented that evidence to the T cells, and T cells went and presented the evidence to the B cells, and then B cells proliferated, and now B cells produced antibody. So from day 0 that you're infected until you produce antibodies probably takes approximately 7 days. So you had non-specific defense, and now you move to the specific defense.